Okay, so um, I'm glad that I can share chapter 2, Hadoop cluster. In this chapter, I'm going to focus on Hadoop file system. Okay? So if you, I'm not sure you recognize that the all computer has different file system or not. So for example, if I'm using the Windows computer, there's a Windows file system. And if you are using Mac computer, Mac has its own file system. And if you are a Linux user, like, in lab one, you play with the Linux and Linux file system, it means that Linux has its own file system as well. Similarly, um, Hadoop, like the big data Hadoop solution, has a file system called the HDFS. That stands for Hadoop Distributed File System. Okay, so um, this is what you have to remember. Um, do you remember what are two cores in big data platform like Hadoop? What are two cores? Do you remember two cores? Anyone could tell me what are two cores? Anyone? Okay, so the two cores is file system like HDFS and computing engine like a MapReduce. Okay, so in chapter 2, I'm gonna go over the storage like a HDFS, and then later on, I'm gonna go over computing engine like MapReduce. Again, your computer has storage, right? What is your storage in your computer? Huh? Yeah, SSD or HDFS, right? What is your computing like a device of your computer? What is computing device of your computer? Hmm? Exactly. Yeah. So same thing. So all system has storage and computing engine or computing device. So first of all, let's look at how the file system, how the distributed file system work. Um, Basically, I told you that the big data cluster is composed of three servers, like three nodes. Okay, so suppose that you know the I have three people who compose a team, and then they are three people, but they work like a single person, like a team. They work as a team, right? So same thing in Hadoop cluster. Uh, there are three nodes. Physically, there are three servers, but it works like a single server altogether. That's why we call it cluster. Okay? We call it Hadoop cluster or big data cluster, etc. Okay. So each server has a like a the ability to store data and also process it, because each server is a Linux server and it has a storage and also CPU chip, right? So I can use these three servers as a cluster for storage and computing. And especially for Hadoop file system, um, um, I actually need to if I have a big file, then this file can be split into multiple blocks, and I store each block to each server. Yeah? So it's like if I have one book with the three chapters, then I ask one person to memorize chapter 1, another person to memorize chapter 2, and third person to memorize chapter 3. Yeah? And then if I want to collect entire content of a book, I ask each person to send me like a chapter 1, chapter 2, chapter 3. Then it becomes perfect book, right? So this is like a distributed file system. But the in this architecture, there is one problem. That is, if one person becomes sick, it means that you lose entire book, because you cannot compose a book because one chapter is missing. Okay? So to avoid it, you can replicate the data. I mean, you can replicate the chapter, like, you know, instead of asking one person to memorize chapter one, I could ask two people memorize chapter one and chapter one. Okay, chapter one can be replicated and stored into another server. Okay? So, for example, server one can store chapter one, chapter two. Server two can store chapter two and chapter three. And server three can store chapter three and chapter two or chapter one. Yeah? So if one server goes down, I can use chapter one from another server. So this is, I mean, that's why we need a data replication to maintain entire server works to not to lose any file. Okay? So we always can maintain the reliable system. Also, each server is a Linux server, so it I mean, definitely, each server is a Linux system, so it has a Linux file system. I mean, each server has a Linux file system. And I need to install Hadoop into these three altogether. Yeah, so, when you download the Hadoop and when you install it, even though you use one server, it communicates with the other servers to install entire Hadoop system for all these three servers together. Okay. So basically, simply you just download the Hadoop system and install it to three servers altogether. That as a cluster, that is similar like, you buy a game file, game disk or game file, and then you install it in your Windows system, and you can play game, right? So, the Hadoop system that can be installed in, on top of Linux operating system. Okay. So if you recall what you did in the lab one, you you access one primary node, right? I told you there are three servers, but I only share the IP address over one primary node, right? Because I don't want you to mess with other servers. And if you recall what you did in the lab one, you just run some shell commands, like a Linux shell commands. After that, you run Hadoop shell commands that starts with the HDFS, DFS. Yeah. So, simply, Hadoop file system, Hadoop system is running on top of a Linux or Linux file system. Additionally, like a big data system, like HDFS, it is good for larger scale file. The larger size file. So for example, you may have a file that has size of 10 megabyte. 10 megabyte is like, if you take a photo size is about 5 megabyte, 3 megabyte, right? So you can guess how big the 10 megabyte is. Okay? So if you have a 1,000, for example, image file as a 10 megabyte file size, total data size becomes 10 gigabyte, right? Am I correct? But normally this is not good for big data file system because, you can definitely store those files, but, big data system is to store big size file, such as, if you have 1 gigabyte file, if your file size is over 1 gigabyte, what is the megabyte over 1 gigabyte, by the way? What's, hmm? Oh, yeah, yeah. So simply 1,000 megabyte is like a 1 gigabyte, right? So if you have a 1 gigabyte file, that is about like 1,000 megabyte. So definitely it's a lot bigger than like an image size, right? So if you have a 1 GB file, I mean, if you have 10 1 GB files, total data size become 10 GB, right? So total data size is same for the first case and second case. However, the performance-based, the second case is good fit for big data file system. Like for HDFS, the second is a lot better than the first one. Yeah? Especially for performance. Yeah? You can get much better performance with a big size file in HDFS. So if someone asks you to use a media file like audio, video, image, normally it doesn't work well in HDFS file system. Okay, so you should use like a big, for example, text file that you collected from IoT or from the finance or from the social science, etc. Yeah. Also, your like a transaction data that you downloaded from database that is that has a file size of maybe 2 GB or 1 TB. Definitely, you need to use Hadoop file system. Okay, that you have to remember. And also, this file system is the right ones. As the name said, once you create a file and store it into Hadoop file system, you cannot update small portion of the file. Okay, so you have like 1 GB of file, and then if you want to update a certain part of this file, it's not possible in this file system. Okay? So once you create a file, only way to, you know, uh, I mean, the only it allows the overriding. Like if you have a file one, and if you want to change it, you need another file one that has a change inside. So you need to override it. Or you can append more data into this file. Okay, these two cases are possible, but if you want to only update the part of the file, it's not possible. Okay, that's why it is called the write once. If you write once, that's it. You cannot do anything. You just need to read it. So this is good fit for data analysis, not for transaction. Anyone could tell me what is the best solution or service for transaction? Or what is transaction, by the way? Have you guys heard about transaction? What should be transaction in computer system? Or what is the example of a transaction? Or what is server mostly for transaction? Anyone? Okay, so transaction is nothing else but to update the record like anytime. Like so for example, banking system. When you deposit money, your balance becomes probably 200 from 100, and then if you take out money like $100, then your balance becomes 100 again, right? So if you have like millions of customers who keep updating the balance, then actually database is the good example for transaction. So database has millions of customers record, like profile information or balance information, and depends on how frequently the customer the deposit or take out money. It keeps changing each person's account's balance, right? So it keeps changing the data inside database server. That is called the transaction. Yeah? So for the one of the best solution for transaction is database. Yeah? However, if you try to use Hadoop for transaction, again, that's not possible because you cannot update the portion of the file. Okay? So mostly the big data system is for analysis, not for transaction. Does anyone have any question at this moment? Yeah, so this is what you need to remember. In database community, mostly data warehouse is doing similar thing. Like a data warehouse is to collect the data from multiple databases, mostly for analysis. Okay, so data warehouse is, has been popular for analyzing the data. It's not for transaction because, you collect the transaction data from database, and then it analyze like a customer's behavior or any a transaction like a fraud detection, etc. Very similar to Hadoop file system, but database warehouse. I mean, data warehouse is very, very expensive, like millions of dollars to buy. If you buy Oracle or Netezza database, I mean data warehouse, you need to pay like at least $1 million. Any question at this moment? Okay, let's continue. Let me continue HDFS. As I said, when you save a file, when you save a, for example, 1 GB file, this file is split into multiple blocks. Okay? And then each block, they should be stored into different server. Okay. And then it means that you should have a fixed block size. That could be either 64 megabyte or 128 megabyte. That should be set by system admin. And based on years of experience in industry, the community community has chosen that the optimal block size should be 128 megabyte. So if somebody asks you what is the block size for HDFS, you should answer, you should choose 128 megabyte. Yeah. Very important to remember that. So as I said, if you have a 1 gigabyte file, your file size is 1 gigabyte, then when you store it into HDFS, it is split into multiple blocks. And then if you divide it by 8, if you divide 1 gigabyte by 8, if you divide 1 gigabyte by 128 megabyte, then it becomes 7 blocks with the 128 megabyte block size. And the 8th block has the size of 104 megabyte. Yeah? It is because you cannot you cannot exactly divide it with the 128 megabyte. Let me show you. Okay. So again, what is the size of, what is the megabyte of 1 gigabyte? Okay, so let me just simply type in 1000. Okay, 1000 megabyte divided by block size. What is the block size again? Exactly, 128. Then 7, and there is some remaining, right? So it means that, it should, the one gigabyte can become 8 blocks. Okay? So another word, 7 blocks times 128 equals 896 megabyte, right? And 1000 minus 896 is about 104, right? So, 7 blocks, block size 128 as we expected, but eighth block size is 104 megabyte. Okay, so even though you set block size to 128, you don't need to use entire block, especially for the last block. Okay. Any question about this? Yeah. So if I have 1 gigabyte that I need to store into 3 servers, I need to, I mean, these 8 blocks should be spread out to these 3 servers. After then, to maintain the fault tolerance, assuming that always one server could be down. So you need 3 replica for each block. So if I have 8 blocks, each block there are 3 blocks for each block, simply. Like if you have a block 1, block 2, block 3, block 1 has, you have a 3 block 1, and 3 block 1 should be spread out to different servers, okay, to avoid any loss. So again, if I have a block 1, block 2, block 3 to these 3 servers, and if node 1 goes down, I lose block 1, right? So I don't like it. So block 1 should be stored into 3 different servers if I have 3 servers. And same for block 2, block 2, 3. Block 2 should be stored into 3 different servers as well. And then, even though one server goes down, I can keep, building the file. I can keep compose the file when I read it. Any question for this logic? And this is all, again, the simulate the human society. Okay? It's not created by genius. It is based on humans' experience. So it's like, human always collaborate with other people as a team, right? And then we have experience how to maintain the team to collaborate together, right? So again, if one of your team member is sick, other team member should take over that person's task or memory, right? That's what Hadoop system has built. And also for the team, team has multiple team members, and then definitely you should have a leader and the workers, like a master and workers. Then in your experience, how many leader you need in your team? One? Yeah, mostly you need one leader. I mean, if your team is huge, maybe you need several leader, but if you have for example, 5 team members, 10 team members, you may need only one leader, because this leader can, manage these people. Then how many workers you should have? Is it one or multiple? Multiple, right? So same thing. For HDFS, for distributed file system, you need only one master node, and you need multiple worker node. Yeah? And the master node is called the name node, and worker node is called the data node. Yeah. And then, the role of a data node is to keep the file, the block. So, if I have 3 worker node or 3 people, each person or each node should memorize the block. They need to store the block, and I need to just manage them. Okay. So when I manage them, as a master, when I manage these 3 servers, only I need to remember is what is the file name and what is the blocks that compose this file, and where those blocks reside. Which node keep those blocks. That's what I need to remember. Okay, I don't need to keep the block, but I definitely need to remember what is the file name and what is the blocks that compose that file and what is the location, what is the server that keep these blocks. This information is called metadata. Okay? So metadata is nothing else, but it's like a namespace, or simply it's like a table. So when you remember this, you may use table to say, what's the file name? Maybe file one. What's the blocks? Block 1, 2, 3, 4, 5. What is the location? What is the server that keeps this block? And I can say block 1 is in node 1, block 2 is in node 2, something like that. That's the metadata. There is like a namespace. Okay? So if I look at, if I show you the HDFS architecture, it looks like this. There is one name node as a master node, and there are multiple data nodes as a worker nodes. Okay, and data nodes actually keep the block. The block is shown as a dark green, and the light green is a server. This is server. And the name node keep communicating with this data node, and you also keep the metadata. That is the name of file and the blocks that compose that build this file. Definitely, it also has the information of the replica of each block, and also it knows which node has what block. Okay? So, like the client is like you. Okay, yesterday you run several HDFS shell commands. That is to read the file, or that is to create a file. Okay, so suppose that you have a 1 gigabyte file. You need to run the shell commands, HDFS shell commands, to store this file into Hadoop file system. At the moment, like when you run shell commands to write, in your, for example, terminal, if you run shell commands, HDFS shell commands to write a file into Hadoop file system, like you just type in the shell and you hit the enter key, then in the system, in the Hadoop system, it split the file into multiple blocks, and then it send each block to different node, and that information is stored into metadata of namespace. Name node. Okay? So name node is like a name node create the metadata that says, oh, I have a file one, and it has for example, 3 blocks, and each block has 3 replica, and each block's replica is stored into node 1 or node 2 or node 3, etc. Okay, and then the block is actually spread out to each node to be stored. Okay? Similarly, if you run the shell commands, HDFS shell commands to read the file 1, then it talk to name node first to get the information of metadata. So for example, oh, I want to read the file 1. Okay? So you just hit the enter key, and then the Hadoop system automatically talk to name node to say, oh, this guy wants to read the file 1. What is the block and where they are? Then name node will give the metadata information to client to say, oh, for file 1, file 1 is composed of block 1 to 3, and block 1 is at node 1, block 2 is at node 2, block 3 is at node 3. So you need to contact them to collect those blocks. So, okay, client, I got it. So I contact node 1 to get block 1, node 2 get block 2, and then after it's successful collect all the block, it compose a file, and then as a user, you can see the content of a file. Okay? So as a user, you just hit the enter key and you see the file content, but behind there is a process like this. Does it make sense? Yeah. So, again, if you work as like a programmer or analyst, you just run the commands, but behind this kind of a process has been happening. Okay? So, if you know this concept, when you become for example, system developer, then you could use the same idea that is based on human community experience or based on some system. You can build another distributed file system easily. But again, if you just work as a data analyst or the programmer, then you just focus on writing code. You don't need to worry about how your big data platform is working. Same like you don't know anything about how computer is working, but you use it without any problem, right? Same thing. But if you major in computer science or information system, you also need to know how at least computer is working or how big data platform is working. Any question at this moment? Is it clear for you guys? Good? Okay. So now let's take a look at how we use it, especially with the HDFS shell commands that you already get experienced yesterday in the lab one, right? So you open terminal and you use actually command line interface. It means that you just use a terminal to enter command to play with the file system or to run some shell commands. And um, again, in big data cluster, you use only one primary node, and they are all Linux file system. I mean, they are all Linux operating system with a Linux file system. And then to play with the one primary node's the file system, you actually run shell commands like ls to list the files and folders of your home directory. Also, you can copy and move the files and folders using cp and mb. And you also made a directory named the example, for example, right? So using make directory shell commands. Okay. And these are common for HDFS shell commands. I mean, you can use it as HDFS shell commands as well. Okay, because when the HDFS, I mean, when Hadoop community built the Hadoop system, I mean, they want to use similar syntax that has been popular. Like, if I know shell commands in Linux, why don't I use similar or same shell commands in Hadoop file system, right? So you can use almost same like shell commands in HDFS. Only difference is when you run HDFS, you just type in HDFS DFS hyphen. Okay, that's what you did if you recall what you did. But there are unique shell commands in HDFS as well. There is put and get. Okay? It is because uh, your Linux file system has a file. Okay? So you can put a file from local file system that is actually Linux file system to HDFS. You can copy it to HDFS. Or in the other way, you can copy from HDFS to local file system, I mean local to Linux file system using get. Okay? So using put and get, you can copy Linux file to HDFS file, or using get, you can copy the HDFS file to Linux file. Okay? So again, to use HDFS shell commands, you have to call HDFS DFS hyphen. Let's look at the example. Suppose that you have a input.txt file in your Linux machine. You can copy that and put into HDFS file system using HDFS DFS -put and input.txt. This is a file located in your Linux account, and then you create new file named input.txt that should be stored into HDFS. So it means that this file split into multiple blocks, and each block is spread out to multiple servers. Okay? But in your Linux, if you have an input.txt file, that is only located in your primary node. But when you put this file, when you create new file and put it into HDFS, the new file split into multiple blocks, and each block is spread out to multiple nodes in HDFS file system. Okay? So this is what you have to remember. Similarly, you can also list files or directories in your home directory of HDFS using HDFS DFS -ls and period. Periods means your home directory in HDFS. Normally in Linux, that means current directory, current working directory. But in HDFS, that means your home directory. And also, if you want to list files and folders in HDFS, in the root directory of HDFS, you have to use /. This is same for Linux and HDFS file system. Also, if you want to remove the sales.txt file in the /reports directory of your HDFS, then you can call HDFS DFS -rm. rm stands for remove, and you need to specify the location of your directories. That is on the root directory, and there is a folder and /reports directory has a sales.txt file, so you can locate sales.txt using the path to remove it. Okay? So you can remove sales.txt file from reference directory in HDFS. Does anyone have a question for this? Yeah. Oh, it has. Yeah. Okay, let's see. Oh, for CD, no, because in Linux, you can change your location, right? But HDFS uses like read each directory, but you cannot change your location. A good question, though. Do you know what is a home directory in Linux system? What's the meaning of a home directory? Why we need a home directory for Linux server? Anyone could guess why we have a home directory for Linux? Yes. Oh yeah, actually that's correct. But my question is, why we have a home directory in Linux file system? In Linux. Let me give you some hint. The Linux or Unix, that was very expensive, like for example, 20 years ago, 30 years ago. So if you have one Linux server, if you have one Linux computer or a Unix computer, you need to share it with your team. So like 5 or 10 people need to use this Linux computer all together. Okay? So it means that you create folder, maybe another people can read your folder. That's not you like, right? So to share this computer with the 10 people, I need to create each person's home directory. So you are the only one who can use that directory. No one can read your home directory. Yeah. So that's why when I create your accounts in the primary node of the Linux server in the cluster, um, you have it like a /home and /your account name. That is the directory that you are the only one who can use. If we want to try to read the other people's home directory, it doesn't allow you to read. Okay, so there is a authentication, like a primary, I mean, the privacy, like a reason to do it. And Windows also copied that idea. So nowadays, for example, this computer, this one Windows computer, many instructors share this computer, right? So technically, each instructor has their own username and password. So if I get into a File Explorer to look at other people's home directory in the Windows, it doesn't allow me to read the other instructors' folders and file because there is a privacy. This is called authentication. And like for example, root directory that is used as a /. Normally, I cannot read anything on the root directory because I don't have any permission. I can only read my home directory. If I go to another directory, I can't. Same thing. The Normally, I mean, as a default, you can read other people's home directory in HDFS as well. Um, any question at this moment? Okay. So, this is what you've been doing, right? You open Git Bash terminal or Mac terminal to call secure shell commands to connect remote server. For that, you need account name and you need IP address, right? So using username at IP address with SSH and with the password, you can connect to a primary node of the big data cluster. And then once you get in, you can run shell commands to play with the Linux file system of the primary node. And you can call HDFS using HDFS shell commands to play with the entire node. Okay? So think about this. For Linux computer, suppose that Linux computer has 1 TB storage. It means that maximum file size to store into one Linux server is 1 TB, right? If you cluster these 3 server, then in maximum you can you can store 3 TB file, right? If your file size is 3 TB, you can store that file into using these 3 servers. Yeah, that's distributed file system. So ideally, whenever you add more servers, like if you have 3 servers, 3 times more computing power and 3 times more storage. If you have 10 servers, you have 10 times more computing power and storage power. Okay, so that's why distributed parallel computing system is called the supercomputer. Any question at this moment? Okay, again, same. After you run several shell commands for Linux, like ls, pwd, like a prison working directory, you also can run HDFS, DFS shell commands. HDFS shell commands. Obviously this HDFS means Hadoop distributed file system, and DFS means distributed file system. Okay, and these are kind of the prefix that you have to use to run shell commands in HDFS. Okay? So you did it like -ls and -ls slash to read the the files and folders of root, so you can see what kind of folders exist in root directory in HDFS. And you can even even you can also list your home directory using that, or you can also uh, specify entire path for your home directory, that is /user / your account name. You can also see what kind of user exists using /user, and you can see there are like some username that is mostly ecosystem. Besides, there is a user like a J5. And in your case, if you run /user, then you can see entire student's account name. Any question? This is what you did yesterday, and you will do same thing today. Okay? Just to get familiar with the shell commands and HDF shell commands. So this is kind of a workflow or architecture that you're gonna do in the lab. I mean, the including lab 1 and lab 2, and the remaining lab is mostly for data analysis. Yeah? To do it, you need the data that is stored in Somir. So there is actually the GitHub. There is a GitHub account that I put the data file that allow you to read it remotely. That you will see tomorrow, but not today. But anyhow, it looks very complicated, but it is very simple. This is AWS server. I mean, this is AWS that has our Hadoop cluster, and this is the location of your personal computer. Yeah. So what you did yesterday, I mean, what you did in the lab 1 and what you will do in lab 2 is simply, we have a Hadoop cluster with 3 nodes, right? It has multiple nodes, but in our case, we have only 3 nodes in our Hadoop cluster. And using your personal computer, you can run SSH command with your account name and IP address to connect it, right? So, this picture, this flow shows what you did and what you were doing in lab 1 and lab 2. But only the recommendation, only my suggestion for you to do today is you need to open at least 2 terminals or at least 3 terminals using KeyBash or using Mac terminal. Okay? That is to efficiently complete your lab. Okay? So, when you play with your computer, you open many windows, right? Same thing while you are working on. You don't need to save your terminal. Just open multiple terminals to efficiently complete your work. Okay. So, for example, you can open 3 GitBash terminal, and 2 of them you need to connect to remote server by running SSH command. Okay, and then 1 terminal you can run shell commands for Linux and HDFS. Another terminal you can run Hive beeline that you will learn tomorrow. That is to write the code in SQL syntax. And second one, you use shell for Linux and HDFS as you did in lab 1. Okay. And third one is for your personal computer. It shouldn't connect to the remote server. This is just to download the file from the remote server to your own personal computer. Like for example, after you connect to using a second terminal here, after you connect to Linux primary node of this cluster, you can create the file. And then using the third terminal by running scopy command, that is to remotely copy the file from another server. And you have a server's information with your account name and IP address, right? And suppose that your home directory has a file named test.txt. The home directory can be specified by using tilde character, like a wave character and slash. So if you have tilde slash, it means that I wanna I wanna look at my home directory. And then on the home directory, if you have a file named test.txt, you can transfer this test.txt using scopy to your current directory by using period. Yeah, so that's what you are doing in lab 2. This is most important for lab 2. The other part is same as lab 1, but transferring data from remote server, like from primary node to your personal computer is very important for lab 2. Okay. Oh, by the way, between IP address and your home directory, you should put colon. Okay. So after IP address, colon is to separate your home directory and the file information. Okay. So don't forget to put colon here, and then the tilde slash is to specify your home directory in a Linux file system. And assuming you create test.txt file in your home directory, you can specify test.txt after tilde slash. Okay? And then don't forget period. That is important to say. I want to transfer test.txt file from Linux server to current directory over my personal computer, like my laptop computer. So this is what you should do today. And tomorrow, even you need to read the data file from GitHub server to analyze it. That you will see tomorrow. Any question at this moment? Any question so far?